Alright, we're going to go ahead and get started on the intermediate value theorem. The intermediate value theorem is an existence theorem which states that a continuous function on an interval cannot skip values. What that means in plain terms is that if I have a line and on the left side I'm at 1 and then I go all the way up to 7, in between those two values I must go through 5. So 5 is just an example, but in between 1 and 7 you have to go through 5 if the function is continuous, which means that we never pick up our pencil. So the IVT states that if these three conditions hold, then there is at least one number c in the interval AB so that f of c equals k. So what that means is we basically have that c is the x value and f of c is the y value. And if you have those basic items down, you should be able to answer any questions they ask you. Alright? Alright, so number 1 is that f is continuous on the closed interval AB, so you're going to have to say that every single time. Number 2 is that f of A is not equal to f of B. What that means is if at the interval I know that at A I'm at 7 and at B I'm still at 7, there's no way for us to really know what happened in between, so you have to make sure that they're different values. And then we have 3, that k is any number between f of A and f of B. And the notation that we use for that normally is just to say that f of A is less than k, which is less than f of B. Okay, so if you can prove that, then it's very easy to go through and say that the IVT theorem does guarantee that that value exists. So here we just have pictures. We're going to go ahead and draw some pictures. So I'm going to make sure that we have A and we have B, and then I'm going to just draw a function, any function at all. It's easiest if you make it look like mine. Alright, so this is f of A, and this one is f of B. And then what it says is that there is a c, so we'll say that this one is c, in which case f of c, that's right here, is exactly between f of A and f of B. And notice vertically you can see that f of c is in between f of A and f of B. Now what we have here for number 2 is talking about that the IVT can often help us determine if there are zeros on a certain domain. So if I go ahead and I draw myself the same thing, but I'm going to go through and make sure that I have it cross the x-axis. There we go. So this one would be f of A, and this one would be f of B. And what they're saying is that this ordered pair right here would be c, comma, 0. Okay? So that means that a 0 does occur on that interval. So now we're going to go through and use this on a couple following questions. So it asks for this one, it says, is there a value x equals c on the interval from -2 to 5? So the easiest way to do these types of problems is highlight the interval they ask you about. It says -2 to 5. Whoops, probably make it through 5 would be ideal. Let's see if I can fix that. Okay, so my goal is to find out, is there a value of c, so is there an x value such that f of c, or such that your y value is 1. So we're looking for y to equal 1. Is there anywhere in between the yellows that gets us 1? The answer would be yes, right here at 3.5. So is there a value of x equals c? Yes. At x equals 3.5, the y value is 1. Alright, now we're going to look at the next question. So it says, is there a value x equals c on the interval from 1 to 6? So again, we're going to highlight that interval, 1 to 6. 1 to 6. So is there a value x equals c on the interval such that g of c equals 3? So we're looking for it to be y equals 3. So the question is, when you're scanning, is there anywhere that you can say that y equals 3? And the answer would be no here. So you'd say no. And then what we're going to say is on the interval, the y values range from -1 to 1.5, and 3 is not in between those. Now, something that you have to be really careful about is that you need to make sure that if they ask you about the intermediate value theorem, that you use the requirements that we've stated, but here it doesn't ask you anything about those. So we're just asked to look. All right? So now what it says is it says, does IVT guarantee? So one thing we have to fix here is that guarantee is spelled wrong. Miss Wise is not so bright, she can't spell. Guarantee. Okay, so does it guarantee a value of c on the interval from -2 to 5 such that f of c equals 1? So what we're going to do is we're going to do -2 to 5. And then we're going to, so it says, does the IVT guarantee that the value exists? So remember, we're going to go through our steps. So step number 1 is to find out if it's continuous. Okay, so it has to be a continuous function. So if you notice, this is not continuous on the interval. So we're going to say f of x is not continuous. All right, now for this example, I'm going to go through and show the next step just so you have a good idea of how that works, even though we're well aware that the IVT theorem doesn't guarantee anything on a discontinuous function. So I could basically say right here that it's a no-go. All right, but what I'm going to do is I'm going to do the work that it would take to prove with the IVT theorem that this works. So you're going to do f of -2, f of c, and then f of 5. Our goal is to decide that it fits in between. So -2, at -2 we're at 3. And then at 5 we're at 4. 1, 2, 3, 4. So if you look here, that doesn't even happen here either, because it says we were at 3 and now we're at 4. 1 does not fit in between 3 and 4, so this actually doesn't work in any case. So we're going to have to say no. The IVT does not guarantee that there is a C such that, and I'm basically just repeating what the question asks, because you can never have too much writing in these types of questions. You want to go through and make sure that it's very clear what your answer is, and you can't miss any part of it if you write everything. Such that f of c equals 1. And then we'll say because, and you can actually choose either one, but I think the easiest one is to say that it's discontinuous. And we'll say it's discontinuous at, I think it's 2, but let me double check. At 2. Okay. At x equals 2, just to be clear. Okay? So now we're going to go through and do the second one. It says, does the IVT guarantee, again misspelled, we'll put an A there, that's how you spell guarantee, on the interval from 1 to 6 such that g of c equals 3. So it says 1 to 6. Okay, so we'll go through and say that in the interval, it actually is continuous. So 1, f of x is continuous. Usually you would have to justify this, but since we have a picture of it, you do not need to justify. So it's continuous on the interval, okay? So you could say from 1 to 6, or on 1, 6 is probably a little bit better. So we'll put on 1, 6. Okay, so now we need to do the same exact thing we just did. So we're going to go f of 1, and then we're going to slide down and we're going to go f of c, and then f of 6. They want f of c to be 3, so let's find out if it fits. Okay, so f of 1 is exactly 1.5. F of 6 is negative 1. So the IVT does not, or doesn't, apply because 3 is not in between negative 1 and 1.5. Okay? So the order in which you say that, you should always go from least to greatest. So even though 1 is the higher number and then 6 gives you the lower output, you need to put it in order from negative 1 to 1.5. Okay, so it says what two conditions are necessary to apply the intermediate value theorem. So the two conditions you need, and you have to prove every single time or state that it's a fact, is f of x is continuous, and then you have to also have that f of a is less than f of c, which is less than f of b. Okay? So, one thing that you need to know is that when you're doing something that's continuous, you want to make sure that you know that all polynomials are continuous. So I'm going to put up here, all polynomials are continuous. Now, we had this discussion as to what polynomials are, so you might want to make sure that you're aware that polynomials have whole number positive exponents. Whole positive exponents. So you can't have anything to the 1/2 power, you can't have anything to the negative power, no, nothing like that. Okay? So when you see something that is a polynomial, you can legitimately just state, this is a polynomial, therefore it's continuous. So this says apply the IVT if possible on 0, 5 so that f of c equals 1 for the function f of x equals x squared plus x minus 1. So for this example, you're going to go through and you're going to do exactly what we've been doing before. So we need to determine that it's continuous. So is x squared plus x minus 1 a polynomial? Yes, it is. It has a 2 as an exponent, which is both whole and positive. So f of x is a polynomial. Therefore, it's continuous. Okay? Now we need to go through and do the part where we say f of 0, f of c, and then f of 5. So my goal is to show that it fits in between. So f of 0, I want to show plugging in. I need you to show that you've plugged it in. Okay, so 0 squared plus 0 plus 1 is 1. They want me to say that f of c equals 1. Oh, my apologies. I should probably put minus 1 as it states. That way we can get the correct answer. Minus 1, which gets us negative 1. They want us to get 1, and then we need to plug in 5. 5 squared plus 5 minus 1 equals 29. So, the question is, does 1 fit in between negative 1 and 29? Yes, it does. So, we're going to write that the IVT guarantees there is a C on 0, 5 where f of c equals 1, because f of 0 is less than 1, which is less than f of 5. Perfect. Okay? And that statement needs to be made if it does guarantee, or if it doesn't, then you need to state why it does not. Okay? Now, if they asked you what the C was, so like where is it, or what is the C that makes that f of c happen, and this is on your homework, so you might want to make sure that you look. So if it said which C, so I'm going to put a purple right here, because this is not on there, but what C makes that happen? What you would do is you would put 1 on the left side, because we said this is a y value. So we're going to plug it in. 1 equals x squared plus x minus 1. Okay? And then we're just going to solve it. So that becomes 0 equals x squared plus x minus 2, which you can factor. So we get x plus 2 and x minus 1, and then we solve it. So x equals negative 2 and x equals 1. So you just need to decide which of those actually occurs on the interval they state. They said from 0 to 5. So from 0 to 5, I'm going to go through and I'm going to pick this one because it's from 0 to 5. That's going to help you on a couple of your homework questions, so it's a good thing you've been watching this video. Alright, example 3 says use the IVT to show that x cubed plus 2x minus 1 has a 0 on the interval from 0 to 1. So we're going to do the exact same thing. Number 1, polynomials are continuous. In fact, I like to write are continuous everywhere. Okay? Then number 2 is do the exact same thing. So you have f of 0, f of c, it says has a 0, so that means equals 0. If it says 0, root is the same thing. Root or x-intercept, those are all the same. Okay? And then we have f of 1. Whoops. Okay. F of 1. And we just need to plug it in. So, it says 0 cubed plus 2 times 0 minus 1 equals negative 1. And then f of 1 is 1 cubed plus 2 times 1 minus 1, which is 2. And because 0 fits between negative 1 and 2, that means that it does have a 0. So you would say IVT proves that f of x has a 0 on 0 to 1 because f of 0 is less than 0, which is less than f of 1. Okay? Now we'll go through and it says, for letter A, it says f of x equals x squared plus x minus 4 from 0 to 4. Find C for f of C equals 2. Now, I'm going to tell you that your notes actually don't have this on there. So the wording on this is different on yours. So I would make sure that you understand that it's asking you to find C at the end. So I'd start off with 1. It's continuous. Oops. It's continuous. Okay. Then 2, you're going to do f of 0, f of C, f of 4. They want you to find for where it's 2. And then I'm going to just plug it in. So it's going to go 0 squared plus 0 minus 4, which is negative 4. And then I'm going to do 4 squared plus 4 minus 4, which is 16. So that means that this does occur. Okay? So it asks us to find C. So I'm going to say IVT says it does happen. And C equals, and in order to find that, what you're going to do is set this equation equal to 2. So we're going to do 2 equals x squared plus x minus 4. 0 equals x squared plus x minus 6, which gives us x plus 3, x minus 2. And when I solve it, that gets me x equals negative 3, x equals 2. And on the interval from 0 to 4, your answer is 2. So C equals 2. Okay? So now it says determine if there exists a root between 1 and 2, 4. So let's determine if there is one. We're going to do the same exact thing. So using the IVT, we can prove it. So f of x is continuous, is a polynomial. Oh, we need a. Is a polynomial. So continuous. Okay. Now we're going to do the same exact thing. It says between 1 and 2. I know the wording is different, but we have f of 1 equals f of C equals f of 2. Okay, and they want us to find a root. A root means that we have 0 here. Okay, now we're going to go through and just plug in. So 1 cubed plus 1 squared plus 1 minus 4 is negative 1. Okay, and then we're going to do f of 2, that's 2 cubed plus 2 squared plus 2 minus 4. So that's, oh, I accidentally cubed it twice. Hold on, let me put 2 squared. So 8 plus 4 minus 4, that's 8 is 10. So it does guarantee this. So determine if there exists a root. IVT states there is a root between 1 and 2 because f of 1 is less than 0, which is less than f of 2. Alright, I hope that helps, and that should be everything.